Megan, we miss you. And Taylor who? Oh, Twillis. Okay. Bye, guys. We hope you enjoyed the videos, and not really, but all right. Do you remember where we left off yesterday? Do you remember this piece here that we figured out that the limit as h goes 0 of cosine of h minus 1 over h was equal to 0? And the limit as h goes 0 of sine of h over h was equal to 1? So therefore, this will cancel, leaving you with only cosine. So the whole point of what we did yesterday is we proved that the derivative of sine is in fact cosine. That's really all we did. By doing so, we ended up with two very important limits. And we wrote these down yesterday. The limit as theta, we said, goes to 0 of sine of theta over theta is in fact equal to 1. And the limit as theta goes to 0 of cosine of theta minus 1 is equal, divided by theta is equal to 0. Now, if you remember yesterday, we also talked about this. What is the sine of theta? Or I'm sorry, what is the sine? Oh, excellent. I'll pause the video. Okay. Limit as theta goes to 0 of sine of theta over theta. If you plug in 0, what is the sine of 0? Remember? If I live in the unit circle and I draw an angle of 0, I have a radius of 1, and I go through the point 1, 0. That means I have an x value equal to 1 and a y value equal to 0. Sine is what in terms of x, y, and r? Do you remember? Y over r. So if you take y and divide it by r, you get 0. So the sine of 0 is 0. The cosine of 0 is going to be x over r, which will be 1. And the tangent of 0 will be y over x, which is 0. So, if you did 90 degrees, then you would, put it right there, and you would have the coordinate 1 or 0, 1, and that would change your values a little bit. But you need to be able to find those values. I did give you the sheet the other day, right? On Friday when I was gone. So that's what you need to be able to reference. So we've got that. So sine of 0 is 0. Divided by 0 gave us 1. 0 over 0 gives us 1. But here, cosine of 0 is 1 minus 1 is divided by 0. So we have a situation where 0 divided by 0 gave us 1, and we have another situation where 0 divided by 0 gave us 0. These are interesting types of limits. They come up, and we have to know how to work with them. And we proved why those are what they are. But 0 divided by 0 is an indeterminate value, and we're going to learn later how to work with them even better. So that's one thing you learned. The other thing that you learned was the sandwich theorem idea. Remember how we kind of we set these greater than equal signs up and less than equal signs up? So we kind of pinched everything together. Your last statement was 1 is greater than the limit as h goes to 0 of sine of h over h, which was greater than 1, right? So if that sits between there, and when we flattened it out, we realized that h went to 0, the areas went to 0, so they were actually could be equal at that time. Then you ended up with, what does the middle have to be? It has to be 1. And so that brings us to the sandwich theorem. The sandwich theorem says if f of x is less than or equal to g of x, which is less than or equal to h of x, then the limit as x goes to a of f of x is less than or equal to the limit as x goes to a of g of x, which is less than or equal to the limit as x goes to a of h of x. What does that mean? It's always easier to see things graphically. What that means is if we have a function h that's larger than all the rest, and it approaches a certain number L as x approaches 0, and then you have another function that's less than h the entire time, And then you have another function, g, that sits right between them. Doesn't really matter what happens outside of that area, but as they all close towards 0, you know, if I can figure out that the limit as h approaches 0 is L, and the limit as f approaches 0 is L, what does g have to be as well? Same thing. It's got to be L. It's got to go to L. So if you can sandwich them between, then it works out. Okay? It works out. That's very helpful for us. We'll do some examples of the sandwich theorem later on. Today we're going to focus on this piece right here. Now I want you to take out your notes from section 3.4, 3.5, that this is kind of an added part of. And that's what we're going to work on now, is some of those type of problems. Yes. Yes. We use the sandwich theorem for limits. In order to do your assignment today, you're going to need to make it through a few example problems. And we're going to turn to this side of your notes where you've got this example 3. We're going to left off on Friday with some trigonometric functions. We are going to prove that the derivative of cosecant is negative cosecant cotangent. So all we did yesterday was, by using the sandwich theorem and looking at the limit as h went to 0 of sine of x plus h minus sine of x all over h, we found that the derivative of sine was in fact cosine. Now that we know the derivative of sine is cosine, the derivative of cosine is negative sine, what we can do is we can apply that to find other derivatives. For example, the derivative of cosecant is the same as the derivative of 1 over sine of x. See that cosecant 1 over sine are the same things? I don't know how to do 1 over sine of x unless I use what rule? The quotient rule. So I'm going to take this derivative using the quotient rule, and it's going to come out equal to that. You're going to have to do this on your assignment for 2 problems. Quotient rule says derivative of the top. What's the derivative of 1? 0 times the bottom. What is the derivative of the bottom? Cosine. Times the top, 1. All divided by the bottom squared, sine squared of x. Cosecant is the same as 1 over sine. So I rewrote it as something that I knew. I know the derivative of sine, so that's why I used that. What's 0 times sine? 0. So I'm left with negative cosine of x divided by sine squared of x. Apparently, that is supposed to be the same as that. They don't look the same, do they? But the negative sign, that works out. And I see a cosecant. Cosecant is 1 over sine. So maybe I could pull one of these signs out. So if I wrote this as negative 1 over sine of x, if I pulled that out because I know that's cosecant, what would be left over? Cosine of x over sine of x, which is, as you guys said, cotangent. So you can see here I have a negative cosecant. And then cosine of x over sine of x, as you said, is, in fact, cotangent of x. So we just proved that the derivative is, in fact, that. However you'd like to end your proof, you go ahead. Okay. It's Latin. It means that which was to be proved has been now demonstrated. So, something to that nature. No, not kid. Sorry. Quid. It's an acronym. I don't know. I took Greek, not Latin. Yeah, they're the same thing. Tell the Romans that. The fibia, not the phobia. What about Luke? Huh? What about Luke? Matt, Matt, hold on real quick here. You okay? We brought up the acronym. There's issues with acronyms. I get that. What is your beef with NASA? You don't like NASA because you don't think we should be doing space exploration. Okay, would you would you feel like NASA would be doing a better job if they found aliens? What if aliens don't exist? Then they are doing their job because they haven't found any. Ali- Okay, so we're. I just want to show of hands here. I want to know. I'll give you three options: yes, no, or maybe. Raise your hand if you believe that there is intelligent life on other planets. Okay, shh. Raise your hand if you say, I think there might be intelligent life on other planets. Raise your hand if you say, I definitely do not believe there is any intelligent life on any other planet. Okay, wow, all right. Okay.